All right, my name is Miss T Sweeting, for those of you that did not get it last time. And I'm from the Virtual School Bahamas here in New Providence. So our topic for today, I would have asked last time to give me a topic that you guys needed some assistance with. And for the most part, a lot of persons would have put matter. So we're going to start at the very beginning of this unit of matter. So that's what we're going to focus on today, starting off with the introductory part of matter, which is the states of matter. All right, so that's what we're going to focus on today, and going forward the next few weeks, we're going to focus on this entire unit of matter. Can anyone tell me, and I want you guys to type to me in the chat, right? Can you guys tell me what is matter? Because one of the things that we're going to do today, we're going to be able to define the term matter, and we are going to be able to differentiate between the different states of matter. So if you think you know the answer, type to me in the chat. You don't have to open your microphone. What is matter? Scientifically speaking, how can we define this term matter? Anything you know about it, just type in the chat, whatever you could remember. What is matter? All right, let's take a look. Let's see what people have. Matter is something that takes up space. Okay, very good. Excellent job. Anyone else has something different or anything they can add to it? Matter is anything that has mass. So you both are correct. And guess what? If we combined your two answers, you would have the perfect answer. So matter is anything that has both mass and takes up space, okay, which is the volume of a substance. When we talk about how much space something takes up, we're referring to its actual volume, okay? So to have a complete definition, sorry, let me see, you said the exact same thing. Oh, okay, I see it now. Sorry about that, Anthony. I didn't see the two parts that you put in the chat, okay? Yes, you did put the two of them. Excellent. So matter is anything that has mass and takes up space. When we talk about the mass of something, a lot of persons tend to get mass and weight. These two terms confused. Mass and weight, even though they kind of similar, they are different. So when we talk about the mass of something, mass refers to how much stuff or the amount of stuff that actually makes up that object, or the amount of matter that's made up in that object, okay? Weight refers to, well, how much gravity is needed to actually act on that object in order to keep it centered on the earth. So mass and weight are kind of different. When we talk about mass, we're talking about the stuff that actually makes up the object. When we talk about weight, we're talking about the amount of gravity needed to act on that object to keep it down on the ground. All right. So everything around you, every single thing that you have around you right now is made up of matter. It might not seem that way, but it is. And when we talk about the smallest, most basic part of all matter, it is called the atom. And we're going to get into the atom a little bit later on. But right now, we have our definition. Matter is anything that has mass and takes up space. All right. When we talk about matter, of course, there are three states. I know for y'all, this is a bit of a review. We're just going to quickly go through it. So there are three different states of matter. They are solids, liquids, and gases. Now, to kind of explain these three states of matter. Like, why do solids behave the way solids behave? Why do liquids behave the way liquids behave? Why do gases behave the way gases behave? There is a certain theory, and this theory is called the kinetic theory of matter. So we're going to watch a little brief video, and this video will explain the principles in the kinetic theory.
The kinetic molecular theory is the theory that all matter is made up of atoms and molecules that are always moving. These particles hold kinetic energy and move around in random directions. In higher temperatures, the particles have high energy, and in low temperatures, the particles have less energy. The more energy a particle has, the faster it will move. In solids such as ice, the particles hardly move at all and hold a regular pattern because the energy is low and the particles are tightly packed. In liquids such as water, the particles have more energy and the freedom to move around. Liquids have the ability to flow and fill the shape of any container they are put in. In gases like steam, the particles have the most energy. These particles are sparse and move around freely. Gases are usually invisible to the eye and they can be expanded and compressed in different pressures. All matter is composed of atoms and molecules that are always moving. The higher the temperature, the more energy these particles have, and that is the kinetic molecular theory.
All right, so basically to summarize what the kinetic theory says about the different states of matter, all matter is made up of particles called atoms, and these atoms are in constant motion. Anyone recalls from the video what type of energy is the energy of motion or energy of movement? They would have mentioned it in the video. So these atoms that are constantly moving, they have this particular type of energy. Okay, heat. Okay, heat is not the one that I'm looking for. It's not the energy of motion. Energy of motion is called, thank you, Anthony. Thank you, Janaya. It is called kinetic energy. Okay, so these atoms that are always moving, they have kinetic energy. Now, depending on what's being done to these different states of matter. So if you add heat, for example, to a solid, to a liquid, or a gas, they are going to gain energy. And as they gain energy, their motion will increase. Okay, so if you add heat to a solid, if you add heat to a liquid, if you add heat to a gas, they are going to gain energy, which is going to cause their movement, their motion to increase. And that's basically what the kinetic theory says about these three states of matter. They're all made up of atoms. These atoms are constantly moving due to their kinetic energy. And if you give these atoms more energy, like heat, they are going to increase their motion. Okay? Now, when it comes to solids, liquids, and gases, we know that a solid, when you think about it, a solid looks different from a liquid. A liquid looks different from a gas looks different from a solid, so on and so forth. And this is because of the way in which the particles are arranged in a solid, liquid, and a gas. So who can tell me, and again, you can use the chat, how are the particles arranged in a solid? How would you describe this particular particle arrangement in a solid? Okay, I see structured. Okay, we can use a better vocab word than structured. If you look at that diagram of a solid, how would you describe the arrangement of those particles? All right, I see some persons putting it in the chat. Very good. They are very tightly packed, right? So these particles are very close together or very tightly packed together, okay? So they have very little space between them in a solid. What about in a liquid? What about in a liquid? How are those particles arranged? How are the particles in a liquid arranged? Okay, someone says loose, not really loose. Okay, so they are a bit more loose than in a solid, but we won't describe them as being arranged loosely, okay? All right, liquid particles. Give me 1 second. Liquid particles are somewhat close together, but they are not as close together as the particles that we see in a solid. So that's how they're arranged. So they are somewhat close together, but not as close together as the particles in a solid. So you cannot say, in terms of arrangement of particles, you should not say that solid particles are close together, liquid particles are close together. You have to differentiate between the particles arranged in a liquid versus a solid. And the way in which you would do that is you would say in a solid, the particles are very close together. In a liquid, they are somewhat close together, but not as close in a solid. What about in a gas? Give me 1 second. What about in a gas? How are these particles arranged in a gas? How would you describe it? If you would like, you can use your microphone. That's not a problem. So how are they arranged in a gas? Look at the gas diagram. How would you describe that arrangement of particles? Okay, so they are widely dispersed, okay? They're moving freely, good. All right, so right now we're just sticking to the arrangement of the particles, okay? So when we talk about the arrangement, not the movement yet, we didn't get to the movement yet, but their arrangement, we will say that these particles are arranged very far apart from each other. They have lots of space between the particles. So just going back over the arrangement of the particles in solids, they are very close together, very tightly packed with very little space between them. In liquids, they are somewhat close together, but not as close together as those in a solid. They do have a little space between them as well. And in a gas, these particles are very far apart from each other with lots and lots of space between the particles. Now, in terms of the movement, look at the solid particles. They are so close together. How do you think these particles move? Anyone has any idea, can remember? How do these particles move? Okay, someone said slowly. Okay, slowly. Are they able to move freely? Yes or no? Are they able to move freely? What do you think? No, they're not. Okay, so with solid particles, because they are so tightly packed together, they cannot move freely in different directions. Instead, what they do is these particles, they vibrate in their fixed position. Okay, so they don't have the ability to move freely like we will see in the other states, but they are able to vibrate in their fixed position. What about in the liquid? Are these particles moving freely? Are they fixed? Like in the solid? Tell me. Now, in terms of, I see people talking about the speed, right? So again, in terms of the quickness, we know that solids have very little energy, the particles between them. Um, yeah, it does. So they tend not to move as freely as with the other states of matter. The particles in a liquid have a bit more energy and they're able to collide with each other and move around each other in random directions. So these particles, they collide. What does that word collide mean? Anyone knows? If they are colliding with each other, what does that mean? They are coming together. Yes, okay? So they kind of come together and move over each other. And then lastly, we have the particles in a gas. These particles move very quickly in all directions. So when we talk about the speed, right? How fast these particles are moving. Gas particles move faster than liquid particles. Liquid particles move faster than solid particles because of the energy and spaces between the particles. Anyone have any questions on this? Just a bit of a refresher to kind of get us thinking about these different states of matter. All right, so we have our first checkpoint of the afternoon. And so what I want you guys to do is go to www.kahoot.it. I'm also going to put it in the chat. Give me 1 second. I'm going to stop sharing from there. All right, so I want to put the link in the chat. Send it to everyone. And if you would like, you can just click on the link there. All right, so the rest of you, I'll give you guys about 30 seconds more to get on, and then we're going to get started. All right, 10 seconds. Let's go, everybody. Okay. So let's get started. These checkpoints are very, very quick. Only a few questions to kind of get you guys, keeping on top of the information and seeing if you remember what we just discussed. So question 1. Which of the following statements is not a part of the kinetic theory of matter? Which of these statements is not a part of the kinetic theory of matter? All right, so the more energy given to particles, the slower the particles move. That is not what the kinetic theory of matter says. It says that the more energy given to particles, the faster the particles will move. And of course, all matter is made up of atoms, and these atoms are in constant motion. All of that was a part of the kinetic theory. Good afternoon to those that are just joining us. If you are able to, you can still get on to the game with the game pin on the screen. If you go to kahoot.it, put in the game pin, or you can use the link that I just sent back in the chat. All right, excellent job, my two persons that got that one correct. Let's see if we all can improve on our scores now. So particles in a liquid are, do they freely move and flow past each other? Are they tightly packed? Are they different sizes? Do they randomly move? Let's see if you guys got this one correct. I know you guys were going to be torn between those two. So in a liquid, the particles are freely moving. And once you see that word flow past each other, that's a given. Okay, students, that is like a giveaway. So flowing past each other or being able to move past each other, that is something that is unique to liquids. All right, number 3, which statement of matter has particles that vibrate in their position? Which one vibrates in their position? And the correct answer, solids. Solids, of course, have those tightly packed particles that are only able to vibrate in their fixed position. Which state of matter is shown in the diagram? Let's see if y'all remember how those diagrams look. So which state of matter is shown in the diagram? Okay, I have, oops, so, okay, so that one actually is a liquid. So those persons that put liquid, that is correct. The Kahoot put the wrong answer in. So that should have been liquid, okay, not gas. So apologize to those persons that would have lost points on that. That's the computer fault, not my own. Don't blame me, please. So let's see if they do it again. I think they put the question back again. All right, so now this one, they gave the correct one for. So that one is liquid. Very good. Which state of matter has particles that move the fastest in all directions? And the correct answer is gases. Gases have particles that move the fastest. Number 7, particles in a solid are what? Particles in a solid randomly move around, are all different sizes, freely moving, and flow past each other, or are they all tightly packed together? Please let them get this. Okay, so most of y'all got this correct. Excellent. They are tightly packed together. Very good. Okay, number 8. Which state of matter has particles that collide and move past each other? Which state of matter has particles that collide and move past each other? And the correct answer is liquids. Again, I told you when y'all see particles move past each other, colliding, that is liquids. Because even though they're kind of close, they do have some space between them, but the space is not that much like how we see in gases. So they do tend to collide and able to move past each other. Number 9. Which state of matter is shown in the diagram below? Boy, y'all getting these answers in quick. Quick, 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 quick. I hope they're right. All right, awesome. Majority of y'all got that correct. It is solid. That is a solid diagram. And the last question, particles in a gas are, read each statement carefully, find the best suited answer. Particles in a gas are randomly moving all around in all different directions. So that would be the answer there. Now, we're not going to do the podium for this one because we did have a little hiccup. So I'm going to stop sharing from here. I'm going to stop sharing from here. We're going to go back to our PowerPoint. All right, so now for the second segment in our session, we are going to be discussing how matter is able to change state. So we need to explain, well, what is needed in order for matter to change state and describe the various change in state processes that occur. So can anyone tell me, what do you observe happening here? You can use the chat. If you want, you can use your microphone. Any which one is fine with me. What's happening here? So we have I know we have some eggs. Those are eggs in there. Can you tell me what's going on? All right, so I have someone say a liquid is turning into a solid. Okay. All right. A liquid turn. Okay, so I see someone put a liquid turn into a solid. All right, so let's see what's going on. In order for matter to change state, students, what do you think is needed for this to occur? Just think about it for a second. In order for solids to change to liquids, for liquids to change to solids, for gases to change to liquids, liquids to change to gases, what form of energy is needed to do this? And I have someone who put in the chat, a couple persons say heat energy, and you are absolutely correct. All right, so we know that matter can exist as a solid, a liquid, or a gas, like we learned a few moments ago. However, matter can change from one state to another when heat energy is either added to that matter or it is removed from that matter. So you can either add heat to the matter to cause it to change to a different state, or you can remove heat from the matter to cause it to change to a different state. So adding heat makes the particles move faster and spread apart, like we would have kind of discussed when we were talking about the kinetic theory. So adding heat, adding energy to the matter causes the particles to move faster and the particles spread out as you add heat. When you remove heat from the matter, the particles then slow down and they move closer together. So that's a very good comparison to know, students. So if you are adding heat to matter, and you had to compare the movement and the arrangement of the particles when you add heat, you will say that the particles move faster. That's how they're moving when you add heat. And their arrangement, when you add heat, they are spreading out. When you remove heat from matter, the particles are moving slower. So that's their movement. They move slower. And their arrangement, well, they move closer back together. They don't spread out like what they did when you added heat. When you're removing heat now, they move closer together. All right. So here are the different change in state processes that you guys should know at this point, at this stage. So the first one we have is melting. And I want you guys, notice I have everything covered up because I want to hear from you. What happens when matter melts? So what's happening in this process? Go ahead, Aaron.
It is
Oh,
solid
oh,
liquid or turning
oh.
into a liquid.
Okay, good. I got the last bit of that because your audio was a bit muffled, but I heard solid changing into a liquid. And that's exactly right. So melting is a process that involves solids changing to a liquid when heated. So is this process involving heat being added or heat being removed? Do we have to add heat to the solid for it to change to a liquid, or do we remove heat? All right, so we have to add heat. Heat is added. Very good. What about freezing? What happens during the process of freezing? Okay, so we have to remove heat. Good. You are removing heat, and this occurs when liquids change to solids. When you cool them enough, a liquid can change into a solid. Like when you make it ice, for example, you take the water, you put it in your ice tray, you put the ice tray inside the freezer, and you cool down that the water in that ice tray. You cool it down enough and long enough that that liquid water changes to solid ice. And you do this by removing heat. Okay, you're moving heat, you're cooling it down, removing heat from that matter. What about evaporation? What happens during evaporation? All right, so in evaporation, we have liquids. I see some persons putting it in the chat, liquids changing to gas when heated, but I want to add just a little bit more into that. So yes, it is when liquids change to a gas when heated, and this process occurs at the surface of the substance. So evaporation occurs at the surface where liquids transform or change into a gas, and of course this will involve heat being added to that liquid. Now, the reason why I said with evaporation, I wanted to add on that little extra bit of information talking about the process occurring at the surface is because there's another process called boiling where we have liquids changing to gas when heated. But the difference is with boiling and evaporation, boiling occurs throughout the entire liquid and produces bubbles. If y'all ever boil water on the stove, let's say y'all was gonna cook some noodles or some crafting or whatever y'all was cook, I don't know. And you boil that water, you will notice that after some time, after you turn that stove on and that heat gets to that water, after some time, you will notice that there'll be bubbles produced throughout the entire liquid. And this is what we call boiling. Those bubbles are the liquid changing to a gas. And like I said, this occurs throughout the entire liquid, whereas evaporation only occurs at the surface of that liquid, where the liquid on the surface will change into a gas. Okay, so these two processes involve heat being added to the liquid. Condensation. With condensation, anyone knows about this one? What happens in condensation? All right, good. I see some persons putting in the chat. So condensation happens when gases change to a liquid. When you cool them down enough, gases will change into a liquid. All right. So for example, I don't know if you guys ever took a cold soda or a cold juice out the fridge and you rest that down. After some time, you should notice some little water droplets on that soda can or that juice can. Now, y'all know where that water come from. Like, you ain't pour no water on your soda can, but because of the process of condensation, that gas got cooled down enough where it transformed or changed into a liquid state now. Okay? Another process that may be a bit new for some of you is a process called sublimation. Now, sublimation is very unique in that this process occurs when solids change directly to a gas. Notice what it says, students. Solids change directly to a gas. It doesn't go from solid to liquid to gas. The solid goes directly to a gas, okay? So the liquid phase is skipped. And this happens when heat is added to the solid. All right, this can happen with certain solids. Not every single solid can go through the process of sublimation. I'm going to give you guys an example on the next slide when we go through it. All right. And the last process that also might be new to you is deposition. And deposition is the opposite of sublimation now. So now we have gases changing directly to a solid. So skip the liquid phase, gases change directly to a solid, and this happens when heat is removed now. Okay? I didn't mention it earlier, but I told persons who came to the class on Tuesday, as we go through this information, if you guys have the ability on your devices to screenshot anything that you may want to keep for your own reference, you can go ahead and screenshot it. That's fine with me. You can go ahead and do that if you would like. Okay. So on the next slide, we have our example here of sublimation. Anyone knows what this is? Look at the bottom picture. Anyone knows what that is?
Solid to gas.
Dried ice. Very good, Janaya. It is dried ice. Dry ice is a perfect example of sublimation. Here we have our solid dry ice, and when heat is added to this dry ice from the environment, we see this smoky looking thing, this smokiness coming from the dry ice, and this smokiness is the gas. So we go on straight from a solid state to a gas state. No liquid phase. No liquid phase. Solid to gas. So a good example of this, like I said, is this dry ice. And with deposition, anyone knows what this is? To the bottom right, what that stuff is on those fruit on the plant. Frost. Excellent. That is frost. Frost is a perfect example of the process of deposition. So here we have gas in the form of water vapor. So y'all know water vapor is water in the gas form. So when water vapor is cooled down enough, and of course this happens in very cool countries that have temperatures that can cool down this gas enough where it will change into solid frost. Doesn't go from water vapor gas to liquid to solid. It goes straight from the gas state directly to the solid state. All right. So let's try this one together, and then I'm going to give you guys one to do as well. Can you guys tell me what A, B, and C is first off? What is A? So if you see a diagram like this on an exam and it asks you to label A, what would you say A is? That's a solid. Excellent. What is B? B is a liquid. And then, of course, that makes C our what? C is pointing to this smoke stuff coming from the kettle. That's our gas. Excuse my handwriting. I promise y'all, I do not write like this on regular paper. Okay? So let's look at number one. Number one is showing, let's look at the arrow. So when we have diagrams like this, we got to follow the arrow. So this arrow is showing a solid changing to a liquid. What process would that be? Solid changing to liquid. That would be melting. Excellent. Melting. Good job. Number two shows, well, we have the arrow going the next way. The liquid changing to a solid. Liquid changing to a solid. What is that process called? Very good. I see my answers coming in quick in this chat. Excellent job, students. Freezing. All right, number three, we have liquid. If you follow the arrow, liquid changing to gas. What would that be? Liquid changing to gas. Now, if you want to tell me evaporation, I'll take evaporation. Good. And I like evaporation because we know that this one occurs on the surface where particles will kind of evaporate off into the atmosphere. All right, versus boiling would be occurring inside the liquid throughout the whole entire liquid. Let me finish writing my word, evaporation. Good. And number four, we have gas. Follow the arrow, changing to liquid. What would that be? Gas changing to liquid, number four. Condensation. Excellent. Very good. All right. So I helped you guys with this one. I want y'all to do the next one on your own. And the way you're going to do this one is you're going to type your answers to me in the chat. Now, I don't want y'all to send me your answers 1, 1, 1. So I don't want you to say A, send that. B, send that. No. Do all A, B, C, D, E, F. Put all your answers in and send it all one time in the chat to me. So I can give you guys 2 minutes, man. Y'all shouldn't take no more than 2 minutes with this. All right, so tell me, what is A, B, C, D, E, F? There are so many different ways with this particular topic that they can throw diagrams at you guys. So I'm trying to get you guys to see the different ways that they can show you diagrams and expect you to be able to still identify what these processes are happening. So again, just send me your answers. A, B, C, D, E, F, only 6 processes. Send it to me in the chat. Okay. Very, very good. I have my first 100%. Okay, I have another 100%. Awesome. Very good. Okay. All right. Let me see if Janaya can get her last 2 right. Good job, Miss Colebrook. All right, I think most persons who would have submitted their answers would have gotten these correct. So we have A, solid to gas, solid changing directly to gas. I see most everybody put the correct answer, which is sublimation. B, gas changing directly to solid, deposition. C, solid changing to liquid. We have melting. D, liquid changing to solid. That's freezing. E, gas to liquid. That is condensation. And the last one, we have liquid changing to gas. That is evaporation. Excellent job, students. Very good, very good, very good. All right. I'm gonna skip that for now because of the time. And we're just gonna go straight into our very last part for this afternoon, which is on the properties of solids, liquids, and gases. All right, so when we talk about a property of something, anyone knows what this term property means? I don't mean, where your house is. I'm talking about the land property. I'm talking about the scientific definition for a property. Anyone have any idea? Like, how do we, oh, okay, a characteristic. Very good. So each state of matter, I love that word characteristic. Each state of matter, whether it's a solid, liquid, or a gas, has its own set of properties. A property describes how an object looks, how it feels, how it acts, how it behaves. All right, so it describes different characteristics of that matter. A property describes how an object looks. What does it look like? How does it feel? What does it do? How does it act? How does it behave? So that means that liquids look, feel, and act different from solids. Solids look, act, feel different from gases, and so on and so forth. Okay? So, properties of a solid. So we're going to talk about the properties of each one of these. When it comes to the properties of a solid, solids have a definite volume and shape. What does that mean? Anyone can tell me? Can you put that in your own words? Solids have a definite volume and shape. What exactly does that mean? Solids have a definite volume and a definite shape. So when we talk about something being definite, that means it doesn't change. Okay? It doesn't change. All right, I see some persons putting answers. Good. Anthony, good. So solids have a volume that remains the same and a shape that remains the same no matter what container you put it in. All right, when we talk about the volume, remember we said volume refers to how much space it takes up. So no matter what container you put a solid in, it's going to take up the same amount of space no matter where it is. So when solids are described as having a definite volume and a definite shape, this means that they take up the same amount of space and they keep the same shape no matter where you put them, no matter what container they're placed in. Solids, because of this, because their volume is definite and their shape is definite, solids cannot be poured nor can they be compressed. Compress means to flatten by adding pressure. So because of the definite volume and definite shape of a solid, they cannot be poured nor can we compress them. All right, so if you look on the screen, I just put an example, right? So here we have our solid cube inside of a container. This solid cube, even though it's placed in a cylinder-shaped container, or not a cylinder shape, this is a conical, like Y-shaped almost container. Even though it's placed in this container, this solid cube has remained the same shape as it was outside of this container, and it has the same amount of volume. It's taken up the same amount of space as it would in another container or outside of this container. All right, so that's solids. Solids have definite shape, definite volume. When it comes to liquids now, liquids have no definite shape, but they do have a definite volume. And all that means is liquids, their shape will change. Their shape takes on the shape of whatever container, whatever they're placed in, the shape of the liquid takes on that shape. But the space, the amount of liquid, the amount of space the liquid is taking up will not change. Okay? So when we talk about liquids having no definite shape, but a definite volume, this means that the liquid takes the shape of the container they are placed in, but takes up the same amount of space no matter the container it is placed in. Liquids can be poured. We know we can pour liquids, they can flow, but you cannot apply pressure to a liquid and compress it. All right, if you try to compress a liquid, that's gonna spush all over the place. So it cannot be compressed, but it can be poured. And so our diagrams that we have on the screen kind of show us, right? Here we have, if you look at it carefully, let me highlight it for a second. We have a certain amount of liquid. We have 200 ml of liquid in 2 different shaped containers. Okay, so 200 ml is in this first container. Notice the liquid that's in that first container, that 200 ml, has taken on the shape of that container. And when you pour that 200 ml now into this container, it is now taken on the shape of this other much wider container. But the amount of liquid there is, it's still 200 ml. It hasn't changed. That's why the volume is definite. The volume stays the same. How much liquid we have stays the same. The only thing that changes with a liquid is the shape. It's going to take on whatever kind of shape you put, whatever you put it in, it takes on the shape of that particular container. Any questions on that one? I know liquids could be a little tricky sometimes. All right, let's clear these drawings up. So before I go on to gases now, what do y'all think gases will do? Remember, we've been describing the properties of these different states of matter in terms of their shape and their volume. We already talked about the shape and volume of solids being definite. We talked about the shape of liquids being not definite, but the volume is definite. What do you think gases do in terms of their shape and their volume? Let me hear from y'all before I put the answer on the screen. All right, somebody already put it in there for us. Good. Gases, listen, gases do their own thing. They have no definite shape or volume. Gases do not have a definite shape or a volume. Listen, whatever container the gas is in, it's gonna take on the shape of that container. Right now, the room that y'all in is filled with gas. And those gases in that room have taken on the shape of the room you in. Okay? So, gases, no definite shape, no definite volume. This means that the gases take the shape of the container they are placed in, and they take on the space of that container. Okay? So gases not only take on the shape, but they occupy the entire space of that container. That is why gases do not have a definite shape, nor do they have a definite volume. And so because of this, because their shape and their volume is not definite, gases can be compressed. You can compress, you can apply pressure to gases and it will compress. So this is the only state of matter that we have that is compressible. Okay? All right, students, because I don't know, some of y'all might be in grade 8, some might be in grade 7, some might be in grade 9. We are going to stop here for the day. When I see y'all again next week, we are probably going to start the class off. I hope all y'all come back next week, Tuesday, because we're going to start the class off with a quiz on the same properties of matter that we just discussed, okay? So I know our time is up for today. So like I said, we're going to stop here. And when I see y'all on Tuesday, we're going to start with our checkpoint on this particular topic. So you guys have a good afternoon. Y'all be safe. I'll see y'all next week, Tuesday.